Welcome everybody, I'm Bovard, and today we'll be talking about data architecture. And in this forum, I'm using my experience, along with some experiences of some of my coworkers and people I've met, to kind of craft a narrative. And we're actually going to be exploring that using Dungeons and Dragons. And for people who don't know what that is, don't worry, I'll give you the 30-second run through. So first, opinions expressed are solely my own and do not express the views or opinions of my employer. Standard disclaimer. And to get Dungeons and Dragons out there. Dungeons and Dragons is super popular now, thanks to Stranger Things. And to explain it to you in one sentence, real-life adventurers roll 20-sided dice to kill monsters who then turn into gold, rinse and repeat, and you kind of have the idea. And we're going to be doing all of those things today in the context of crafting this narrative around data architecture. And most importantly, these 20-sided dice, the faces are labeled 1 through 20. You roll a 1, it's a critical failure and something bad happens. You roll a 20, it's a critical success and something really good happens. So, Act 1, our story begins. 10 years ago, a band of adventurers take a new quest. A challenge unlike anything they'd have ever encountered, featuring very low chance of success, high risk, high reward, hours of thankless work, no actual questing, no actual combat. We're actually talking, of course, about a startup. And the first thing they went and validated market fit, and there be goblins. And they rolled a 12 and turned the goblins into gold. Then they went to ship an alpha product against the trolls of the world. And unfortunately, the first time they rolled a 1 and it was really bad, but they shipped a second alpha just as quickly and it turned out to be pretty good. So they loaded up with some customers, and as the customers started coming in, so did the data, and the CTO said, wow, we have a lot of data. And luckily, the CTO knew of this Doge meme. And I know a lot of you were thinking, 10 years ago, 2009, well, Doge didn't come along until 2014. You've just dispelled, destroyed the illusion. And I'll ask you just to continue with me. And Doge came down and said, much value. And the CTO said, I've got a great idea. We have all this data. We have Karen, who knows SQL. Let's turn the data into money. We have a lot of data, so we're going to get a lot of money out of this. And this is pretty common at a lot of small startups. There's that one person, they know SQL, they have become the data person. And Karen knows SQL, and hiring Karen was a natural 20, a critical success. She's super confident, she has all the skills she needs, and she steps into the room at the CTO's behest and starts hooking up some of the technologies of the day to make sense of this data and gain value from it. So hook up some Google Analytics, MySQL database, Tableau, and lo and behold, we started making money. So Karen leveled up. She received 1 level of Director of Data Science, and her career started to take off just like the startup. And there was much rejoicing, yay! And her architecture looked something like this. So you've got a MySQL database, relational database, the data is normalized, etc. The shopping cart is the product. The servers and databases that serve that product are that black box. Those are feeding data into Google Analytics. Of course, marketing and sales had to have their own database separate from the main one, but they're a startup and moving fast, so no one really cared. And there's an ETL process moving on the side there, and Tableau starts visualizing what they'd go. And Tableau probably wasn't around in 2009 either, now that I think about it. But so they use the data to make money, and how do they make money out of data generally is to actually make the product better. So with the data, they were able to actually see how users use the product, where their pain points were, and make the product better. And they grew and grew, and that brings us to Act 2, 3,650 days later. So somewhere deep inside the company, a new data hire's first day. And in the 10 years, the company's done pretty well, and they've started to get a lot of data. But something's wrong. They're not quite getting the value that they would want out of the data. And those ghosts didn't turn it too well. But along come the ghosts of bad data. I'm sure all of you have dealt with the ghosts of bad data at some point in your careers. Something doesn't add up, the field is null, something is wrong. And these three are standardization, discoverability, and correctness. So the ghost of bad data standardization, there's a user inside the system. Do we use the user ID, the user number, the user email, the user SFID, the user name, the user hash? Each team is using a different one, right? This is a startup, they went fast. Everyone's using something different. Discoverability, asking questions like, what does team X collect? Well, I don't know, go talk to team X. That doesn't scale once you get out of 20 to 50 employees. Who should I talk to about Y? Do we even know Z? What does this mean? And correctness. Sometimes when people are moving fast, they make mistakes like passing in null for user identifier, or a to-do that never gets done, of course, or passing a string in as an integer. So luckily, our new hire has an idea, which is to use protobuf, or something similar like thrift. So protobuf stands for protocol buffers. How many here are familiar with protobuf? Show of hands, or what it does? All right, a few. So protocol buffers are language neutral, platform neutral, extensible mechanism for serializing structured data. And we'll see what that is right now. So we define a new message type called person. There's a required string name, so that's a typed identifier there, an int32 int, a string email, and then you could put those types into other types. So we define a type, or message type called address book, which has repeated persons inside of it. So you can see how you can build data structures using this. And it even has things like enums. So we could have a enum called phone type, and you can see phone number has a required string number and then an optional phone type. And this is Python right now. You can then use it in any language you want, Python, Java, JavaScript, Go, what have you. And it looks very similar of how to assign fields. And you're probably thinking, okay, it's Python. You said there's types in this, but Python doesn't have types. Well, using this, it actually will raise a type error if you try to assign a string to an integer, or if you try to assign to the wrong field, it will raise an error as well. So you can see how that's going to avoid some of our problems. Then you can serialize protobuf, serialize to string or parse from string. And before this, everything was done with JSON. And I heard a quote once, the heat death of the universe will be caused by the last JSON being decoded. And I think that organizations really don't know how much of their compute resources is being spent encoding and decoding JSON. Protobuf is a big speed up over that, but that's a completely other talk. Finally, we can take all of these messages that the teams have crafted and put them into one central repository, which allows you to do data quality analysis and checking against them. And it's also a really handy way for everybody to know what's out there and defined. So how does protobuf actually beat these ghosts? First, instead of having all these random identifiers to identify a user, we can use protobuf and have standard identifiers like a customer info, which has a required integer called user ID, or an account info for account ID. For the discoverability ghost, we now have our protobuf event catalog where teams went through and they defined a new message, customer login, and customer login would have things like the time and the date and the browser and the customer ID and which account they're logging into. And you can then easily expose that as HTML for everyone inside your company to consume. Finally, correctness, we saw before. You assign a string to an integer and you get a type error. So our new hire uses protobuf. It works quite well. The ghosts of bad data are now piles of gold. And he is really excited. And our new hire's name is Isuf, and he has also stats, but knows a bit about data engineering, which is going to come in handy in a second. Hiring Isuf was also a natural 20. So Isuf has just gone through and he's defeated the ghost and is feeling pretty good about himself. And his first question, why doesn't this add up? In a zombie voice, followed by, when will this report be done? Where did the data go for April 3rd? And on the zombie data questions come, as I'm calling them. The metaphor is stretching slightly here. But so within the organization, there are lots of problems because reports aren't finishing, things are timing out, data is missing. And running away from those questions, Isu's pager starts going off over and over again. Error, out of memory, 503, timeout, latency too high, query canceled, out of mana. And if you remember, this is the data architecture that Karen set us up with 10 years ago, right? Well, today, it looks something like this. Really hasn't changed much, and everything is overworked, and everything is at capacity. What happened? We had Karen, right? 9 years earlier, Karen was thinking, okay, we set up a version 1, we should probably evolve this to scale with the business, but along came a recruiter and said, hey, want to be our CTO? And Karen said, all right. And so Karen went off to another company, and she was a unique hire. She had all the skills to do this, and she was really hard to replace, so they didn't. And this is a common thing that happens to companies. If you don't hire the right talent and retain them and train them, this is a common thing that I've seen many times. So we're stuck with a data architecture like this, and you break one piece of the system and it all kind of falls down. And where we had 3 databases, now we have 6, and they're in different formats, and you can see the different colored lines or different protocols used, and everything is a giant mess. And Yusuf is thinking, how am I going to fix this? And he thinks of a sun and a log, and this is where we're on to maybe broken the metaphor at this point. But let's talk about today's data warehouses, things like Amazon Redshift, Snowflake, Azure SQL Data Warehouse, Presto, and Google BigQuery. So compared to a single instance of, say, MySQL, these have very distinct advantages for analyzing terabytes, petabytes, exabytes of data. First, they're distributed and scalable so that you can actually shove all this data into one of these systems and still be able to query it. Second, they enable some sort of caching. So if your BI layer sends repeated queries over and over again, you can not have them run to the system and churn it down. Third, a lot of these are tunable. And fourth, one of the things that's coming in is a separation of storage and compute. So if you think about a MySQL database, right? It's on a server. That server has, let's say, 16 cores, and it has 1 terabyte of disk space. That's what you have to work with. So at 11 p.m. at night, when no one's querying, those cores are not using anything. And then at midnight, when all of your ETL jobs start, all the cores go up to 100% and they're pegged. When we actually separate storage and compute, we send all of our data over here to our storage layer, and we can fill that up to however much you want. Like in Amazon, that would be S3. You just fill up S3 forever. And in Google, BigQuery does this. Then when you need to execute a query, you go to the giant pool of compute power, and you reserve a couple machines to do the query. And once the query is done, those machines go back into the pool. And this is really powerful because you can get huge amounts of data, store it very cheaply, and then pay as you go as you query. So it doesn't work for all use cases, and none of these are right for all use cases. But we're going to represent this with the sun, because if the data was coal and you put a lot of coal together and it kind of combusts and it becomes a sun. But we're on a road right here, and we can see the sun above us. how do we actually get there? And we get there through a giant log. We're going to build a giant ladder up to the sun. And by this, I mean a distributed log. How many people here have heard of Kafka, Apache Kafka? Yeah. So there are some really good advantages in this particular problem to using a distributed log. But first, some of the advantages. So we've got, Kafka, Kinesis, Event Hubs, or PubSub. They're all very similar. There's one global commit log. So as messages come in, they are added to this log. It's an append-only log. It's write once, append only, read multiple times. So the events are written onto this log once, and then you could have potentially 10 different consumers of this information listening to the log. So it scales out to all of those clients, and they can read it multiple times. It's horizontally scalable. So whether you have 0 people listening to this data or thousands, these systems can all handle that in a scalable way. It's fault tolerant is baked in, so if one of the consumers crashes, there'll be other ones that scale in. And it's actually quite performant. A lot of these systems are getting really good latency. So our architecture today, we have to move towards one repo or one data warehouse that we can all read from. And we can do this in 2 steps. First, don't actually break any of the existing stuff and make sure things are working. Just a slight tweak. Instead of sending the data directly to the whatever you were putting it in, you send it to the log first, and then you have something that reads off that data and shoots it off to the right warehouse. So each is subscribed to the data that they want, but all of the data now is in your Kafka-esque system, your distributed log. And step 2 now, actually getting everything into one of these next generation data warehouses is super simple. Everything's going through your distributed log. So you just take all that data and you shove it off to one of them. And if you want to be cloud agnostic or you're multi-cloud or you want to reduce your risk, you can just shoot them off to 2 of them. It's really simple. You can see how this would take some organizational change. But now you've reduced your risk and you can do more things with your data when it's all in this pipeline. Which brings us to Act 3, the cell. So Yusuf has come up with this idea. How is he going to actually get this implemented in the company? So we've come up with protobuf, the data warehouse, distributed logs, and Yusuf starts talking. And that's one of your jobs as architects, is convincing everyone else this is a good idea and we should do it. So the first time around, distributed logs are great. Oh, these next generation warehouses, it's so amazing. We should definitely do it. And you get a question mark back. So try again. This distributed log system, Kafka, have you seen it? Like, I think it's really great. Oh, is that similar to Stick? No. It's not Stick. It's a distributed log system. Okay, not a Stick, distributed log. Okay, I got it. Stick and distributed log. As soon as you've talked to somebody, they're going to turn around and take what they think they got from that conversation and talk to their coworkers about it. And maybe you think, okay, they've definitely got it, when in fact, sometimes they don't. And if you're not there to talk to that coworker and be there in that interaction and say, wait a sec, no, not Stick, log, it's not going to happen. And then you'll hear a third party. Oh, I heard Sally down the hall talking about Stick. Are you trying to do Stick at this company? Because I don't think it's going to work. And again, kind of going through the organization here. And with each person, you have to communicate, and over-communicate again to get your concepts across and to get your vision across, or you will never affect huge organizational change like you want. So going through and being patient and coming to where people are and explaining to them the benefits is a huge part of your job as a data architect. And finally, when you see people are starting to get the light bulbs turned on and you feel like you've explained yourself really well, it's probably time to get everyone in the same room and talk about it together. Let's do distributed logs. Let's get a next-gen data warehouse. How am I doing on time? Pretty good. And you'll actually see some things come together. And so in this story, it worked out. In many other stories, it doesn't. And I challenge each of you to think about that last step of data architecture and how you communicate. And they were able to get to their next-gen data architecture and pull out some really good insights and scale up the company for the next few years. And all of those pager alerts went away and became piles of gold, but not actual literal gold, or Isuf would be super happy. And all of those zombie data questions of like, my data disappeared for this day, when will this report be done? Those all disappeared. And Isuf received one level of data architect, and we defeated the necromancer. And he said, "Curse you, you haven't seen the last of me," and teleported away. And they responded with a pithy one-liner, which I couldn't really think of anything really awesome, but imagine the greatest one-liner. That's what they said. So tips for all of you for fighting this necromancer when you come across it. The first is be humble and have your minds open to new ideas and changing your mind and working for what's best and what the best solution is given your context. Second is to get buy-in. You can see how Isuf had to go around person by person, changing minds and talking and communicating, and when he thought he was done, communicating again, and keep at it. So things I didn't cover in this talk, because there definitely wasn't enough time. This is very similar to experience I went through. You know, the politics and how to get executive support and the ETL stack rollout and SLO policies and data extraction and display. But that was just kind of the surface. And we actually did this in about a year. So it was end to end. So shout out to some of the folks that let me use their art. Some pretty cool stuff, as you saw. I wish I could make things like that. And you have reached the end for now.
Thank you. We have time for about 1 or 2 questions. Is there any in the audience?
So for distributed log, would you push like all your data to distributed log? Like let's say like you have like a few versions of your data, like raw data plus like a more structured version of the same data?
Yeah, so generally you can kind of push those into different topics, and it kind of depends a little bit. You don't want to push everything into all servers all the time, right? There's going to be some cost to that. So usually there would be some sort of stages to the processing. So maybe you push all the raw data onto something. It gets soaked up by something like Spark or Apache Beam and pushes the data back on, and then it goes through another processing step. And sometimes you want to store off the raw data also into just store it raw into a cloud storage somewhere. So it's kind of multi-stepped, I think, the tiers. But the end result is it all kind of hits logs at certain times and then goes to the right places.
Any other questions for the speaker?
Do you think that if you go in a different approach, like if you don't go with the data catalog first, you will have a problem later on if you just go directly to the log?
Say that again?
If you go without doing your due diligence and you just start throwing everything to Kafka, will you have problems later on without sorting all that data?
Yeah, so if you're just throwing everything into the log without really thinking about it, and then you're just storing it, you're kind of going to run into the problems of data quality and consistency, A, and B, kind of cost scalability issues potentially. If you're just throwing everything without regard into there, kind of garbage in, garbage out, right? You're going to have to do some analysis. But storing things off as a first step isn't a terrible idea, especially to get things moving in the right direction.